Okay. Let me share the screen. So find the values of the derivative if it exists at the indicated extremum. So extremum basically means one of these like valleys or uh, peaks right here. So these are extrema. They may or may not be the minimum or maximum, but minimum and maximum values will happen at extremum. Okay.
Okay.
Now, derivatives at this point would be equal to zero because the horizontal tangent would be a straight line. You see that?
Yes.
So right here we have a tangent of a straight line, straight line. So that means your slopes are zero. So if I set the derivative equal to zero, then I can solve for whatever these points are. So everywhere over here, we're increasing. But once we get to one of these values, we go from increasing to decreasing. That's one way you can determine if it's a maximum. You go from plus to minus, increasing to decreasing, and then decreasing to increasing, you have a minimum, which we'll talk about when we do the first derivative test. So that's our the big picture ideas. Extrema are peaks and valleys. They also occur when the derivative is not defined. You have like a weird cusp. You see a little sharp edge. So these are also extrema value. So if it's defined for the original, see how right here -7 is cool, right?
Yes.
But if you take a derivative, you can end up with a negative power, which means you'd have division by zero. So if it's cool in the original but not the derivative, then that is also a critical value, which kind of hints at another extremum. And usually this type. Okay. So critical numbers are the x values where you have slopes of zero. So these are whatever x value this happens to be, that looks like a 3, right? This one's a 9.
Okay, so critical values are where x equals 0.
Yeah, it's where the derivative is equal to 0, where you have these peaks and valleys. Those are the x values and of this location is the critical numbers. And they just happen to be they also happen to be extrema.
Okay, that makes the homework made more sense. Okay.
Okay,
I was
so
wondering what the definition was because I ended up getting all the critical numbers too, but it took me a while with trial and error to figure out which of the numbers were critical.
gotcha. Yeah, I need to also extend some of those dates. I think they're all messed up.
And the test, you said you were going to have the test due this week?
Yeah, let me do that now before we go forward. But let me check the syllabus, get an idea where the heck we are.
Well, no, we're now on extremas, so 8.
So it looks like we're on schedule. Week 8. We're doing this guy. Yeah, looks like we're fine. Okay. But yeah, let me extend those real quick. All right, so they give us a function, and they want us to find the derivative at the indicated value. Now, if you didn't have a graph and you didn't know what the extremum was, what you would do is take a derivative first. That'd be you bring down to 2/3 times derivative of the inside, of course. Subtract the 1/2. Inside derivative would be 1, right?
Yes.
So that'll become 2/3 times x plus 3 to the 1/3. Okay. So notice that here, -3 is fine, but over here it becomes undefined point, right?
Yes.
So because of that, it is an extremum. So f of -3 is equal to 0. The derivative at -3 is undefined. So this tells us critical number at x equal to -3. That makes sense.
Yes.
So this tells you it's an extrema. So if you didn't have the graph, right, you would have these hints, and then you would use different techniques to figure out, okay, is it a maximum, is it a minimum, etc. This question just said find the derivative at the value undefined. They didn't ask for anything else, but I just wanted to show you that this is a critical number. Okay, anyway, let's move on. Okay. Find the critical numbers of this function. So the step-by-step process. So step 1, find f prime. So take your derivative. That'll be 4x cubed minus 24x squared. Step 2, set f prime equal to 0 and solve for x. You get 4x cubed minus 24x squared equal to 0. So when you solve for this, those x values will be your critical numbers. Critical numbers are potential extrema or minimums and maximums. So factor this guy out. They both have at least 2 x's, right? That'll be sorry, spaced out. 6. Okay, so set each part equal to 0. So x is 0, x is 6. So these are my critical numbers.
Yep.
Nothing too crazy, right?
Nothing too crazy at all.
Let me move this a little bit. But so far it makes sense.
Yes.
Okay, so that's all there's to example 2. Now, there's another rule. Yeah, I forgot which. I'm pretty sure it's in this math book, but I think when it comes to finding maximums and minimums and optimization, a very popular theorem that says that maximums and minimums will occur, are guaranteed to occur within a closed interval. Could happen at the endpoints or it could happen at a critical number. Okay.
Okay.
So the next example would be a closed one. Find the absolute extrema of f of x equal to x cubed minus 3/2 x squared on this interval. So max dash min will occur at the endpoints -1, 6, or critical number. So we can only do this for closed. So step 1, find the critical numbers by finding derivative. So that would be 3x, right? Yeah. Step 2, set it equal to 0 and find your critical numbers. So you'll have 3x squared minus 3x equal to 0. 3x in common gives us x minus 1 equal to 0, right? So 3x equals 0 implies that x is 0. X minus 1 equal to 0 implies that x is 1. So now we do the testing. Test x equal to 0, 1, -1, 6, and determine which ones are the max and min. So basically, what is the biggest one and the smallest one? That's all you got to do. But you got to plug them into the original though. So f of 0 is 0, right? Maybe that's the smallest one. I don't know. F of negative, well, f of 1 or -1, I guess. I don't know. Doesn't matter. That'll give us
I
1
always,
minus. I'm sorry. Go ahead.
I always love doing this part in calculus because it's this break in the middle of the year where finally things make sense again. Like, look, concrete answers.
Yeah, we're actually applying it to something, right? That's true. Okay, f of -1. That would be -1 cubed minus 3/2 times -1 equals -1 plus 3/2, 1/2. Okay. Table. All right. So 0, 1, -1, and so now we just need 6, right? Oops. That should have been squared, which would have stayed negative. So this should be negative.
-5/2, right?
Yeah. All right. 6 times 6 times 6 minus 3/2, 6 squared, something like 216 minus 54, which is 162. Okay, so maximum would be that one, right?
I sure hope so.
6 comma 162 minimum at looks like -1. That makes sense.
Yes.
So whenever it's closed, you can just do that. Test, just see what's bigger when you plug in the endpoints and critical numbers, and that's it.
I mean,
All right. All right, let's do another one, and we'll guess maybe call it a night if it makes sense to you.
sounds good.
The roles there I'm not gonna cover. So if you want, there's some videos in there. It's just like 2 questions, I think.
Okay.
So I'm just gonna, next time I see you, or next time we do lecture, we're just gonna move on to first derivative test.
Works for me.
Find the absolute extrema of. So same type of question, is just that it's a trig type. Re cosine x from 0 to 2 pi. Okay, so same steps. The first step is find the derivative. What's the derivative of 3 cosine?
-3 sine.
-3 sine. Okay. When is sine equal to 0? Do you remember? Oh, the unit circle.
Man, I never ended up memorizing the unit circle.
It's okay. It's going to be 0 at x equal to 0 and x equal to pi.
Like,
So
there's
now
too
we
many
test
fiddly
these
bits with
two.
trig.
What's that?
There's too many little fiddly bits with trig, so I'd end up just working it out on my calculator each time.
That's okay. I only remember the ones that I use the most. The rest you can kind of figure out once you memorize pieces of it, but it's not a huge deal. Again, criticals and the endpoints. To determine what is the biggest and smallest, max and min. All right, so here we go. F of 0 is equal to 3 cosine of 0, which is 3. F of pi is equal to 3 cosine of pi, which is -3. F of 2 pi is 3 cosine of 2 pi, which is equal to 3. So it looks like there's 2 peaks. So maximum, minimum, maximum. So absolute max at 0, 3 and 2 pi 3. Absolute minimum at pi and -3. And that's it. Just for fun, let's graph this guy.
Is that when you knew you should be a math professor when you said just for fun, let's graph?
The what? Sorry.
It's like, is that how you found, like, you knew in your heart you should be a math teacher because you heard your voice saying, just for fun, let's graph?
I see one of my professors back when I was in community college. He was he would always teach Cal 3 every semester, and we do the most ridiculous problems, and then he would go off and just say, just for fun, let's do this crazy thing. And we all just thought it was hilarious. It's like, why? I can't believe this guy's doing this just for the hell of it. Yeah,
Sure, I do
to
the
think of
same
him now,
thing.
I'm just like, you know what? It can be fun, I suppose. But
It is. I had no right saying anything. I do the exact same thing. I'm like, well, what happens if we do this? Like,
yeah, it's
the
just
problem.
it's like we're just playing around. You know? All right, but as you can see, right, is this peak, this valley, smallest and biggest. That's why we call it global max, global min, because it is the highest point. But we're only looking at 0 to 2 pi, which is here to here-ish. But yeah, that's it. Do you have any questions on what an extrema is, what is a critical number, and what the procedure is to find them?
No questions at all. The critical number one got answered. That was the only thing I was confused about with the homework. I could not remember what a critical number was, and I did not want to look it up. There's just
Well,
like this block. I'm like, I'm not gonna Google it. I'm gonna figure it out.
oh, now we got it. It's all good.
Yes.
Let's see. Let me look at the syllabus before I let you go, because I always forget. All right. Yeah, so Rolle's theorem, I'll let you guys deal with it. So next week we'll do 4.3.
Okay.
Which is the increasing, decreasing, and the first derivative test.
Sounds
And
good.
then a week after that, we do second derivative test, some other stuff, and we'll get closer and closer to test 3. So I would say in like 3 weeks-ish, or a month, exam 3 will be waiting for you.
Okay.